physics practicals, electricity, investigation of Ohm's law. Now, I'll first and foremost start by showing you the apparatus that make up this experiment. This is what we call resistant box, and this is the battery cage. This is called the switch or the key in physics, and this is voltmeter. This is 2 ohm standard resistor. This is 1.5 volt cell and 1.5 volt cell. I'm going to join it together to give me the total of 3.0 volts. Now, the very first thing to ensure wire carrier physics experiment, first, you must arrange the apparatus as shown in the diagram given to you. Now, if you look at this diagram, this electricity diagram, here we have the resistant box, and all these lines you are seeing here, all these lines represent connected wires. Okay, from the resistant box to the switch, this sign represents switch or key in physics, and this is a connected wire directly to the voltmeter, directly to the cell itself or the battery cage. From the cell to the voltmeter, directly to the 2 ohm standard resistor. So first, I'm going to arrange the apparatus as shown in the diagram. This is my resistant box as shown in the diagram. From the resistant box to the switch, so I'm going to connect it. Now, one of the precautions of this experiment is that you should ensure clean and tight terminal connections. If you look at this resistant box, here we have graduation of 1, and this side gives us 2 and the rest. So now, here in the diagram, we are giving some given values of resistance to be 1, 2, down to 5. So while connecting this, we're only going to connect to the terminal that carries this one, while we leave this one open. Because if you close it, you are going to have the wrong reading. Okay, so according to the diagram, ensure that my key is open. So from the resistant box to the switch, now from the switch itself to the voltmeter. So I have to ensure clean and tight terminal connections. All these points are what we call terminal. You have to be very tight to avoid random errors. Okay, from my voltmeter to the 2 ohm standard resistor. Then from the 2 ohm standard resistor back to the resistant box. I'm going to join these two terminals together in order to obtain accurate reading. Okay, joining these two terminals together, bring it directly to the terminal of the resistant box. Okay. Now moving down to the table of observation. According to the diagram, we have resistant box, we also have the voltmeter to measure the amount of potential difference. So now, here in the diagram, we have the value of the resistance, the voltmeter, and inverse potential difference. Now, according to Ohm's law, the current I passing through any metallic conductor, is directly proportional to the potential difference V across its ends, all these ends of the terminal. Now, provided that the temperature and other physical conditions of the conductor remain constant. So from here, if we have that V equal to IR, so as the resistance of the wire increase, the potential difference also do increase. So in some case where you plot a graph of R against inverse V, you are not going to have a straight line graph, because R is not inversely proportional to what? V. So if you plot a graph of R on the vertical axis against inverse V on the horizontal axis, you are going to have something of this nature, or you are going to have a graph of this nature. You are not going to have a straight line graph, because R increase as potential difference also increase. Okay, let's carry out the experiment. So first, I have to read and record the electromotive force of the cell that I use, which I have done here, 3.0 volts. Now, how do I carry out my practical for the reading of 1.0? First, here we have 1. Bring the camera close. Bring it close. Here, this is 1, 2, and we have another 2. So for us to take the reading of 1, I'm going to ensure that the 1 The part that I'm dealing with one is open. I leave it open. Then I take the reading. Now it deflects. Bring the camera close. Bring it to this side. So have you seen it? So it has deflected. The ammeter, if I remove the key, it returns back to 0. Now, one of the precautions of this experiment is that you have to note and correct 0 error. So this is the point at 0. So when I close my key, it now give me 2.20. Okay, I'm going to repeat this experiment for 4 other values. Pause. What we have 2.20. So at this point, when R is equal to 1, the reading of the voltmeter is 2.20. So we are going to repeat this experiment for four other values of 2, 3, 4, and 5. So following the same process, everything the same process remains the same. You can evaluate this. V inverse simply 1 all over V. This should give us 1 all over 2.20, which gives us 0.45. 0.455. 0.455 because we are using 3 decimal here because it's an evaluated value. So we can repeat this experiment for this other value. So, according to Ohm's law, as the resistance of the wire increases, the potential difference also increases. That is to say, moving down, this will also increase. The value of the potential difference will also increase. So, taking the reading for 2, taking my reading for 2, another precaution of this experiment is to ensure that the key is open when no reading is taken from the circuit. So, taking the reading of 2, bring the camera close. So, this is 2. I ensure that 2 is open. And now close my circuit. So this gives me 2.60. So 2.60. 2.60. So as this increases, the value of the potential difference also increases. Okay. For more updates on physics practicals and standard graph and every other aspect of science, if you have not yet subscribed to this channel, do go to hit on the subscription button. Thank you.